Yeah. I'm not sure if that
We're still sharing. All right, so we're going to talk about safety in three different kinds. And we'll talk about electrical safety, which is the really serious stuff because it can kill you or hurt you. Um, most of the stuff we deal with in handy talkies, base station transceivers, you're not talking about very high voltages or currents, although there's RF, which can give you a nasty burn. When you talk about things like power amplifiers, finals, particularly old tube types, you're talking thousands of volts, 3,000 volts on the tubes. So if you go working on those, you can get a significant shock. And we'll talk about some of the things that you're supposed to do to keep that from happening. They claim that voltages above 30 volts or currents above 100 milliamps can cause heart fibrillation. It's kind of a weird range. Lower than that, it doesn't do anything. And when you get much higher, you don't get heart fibrillation, but you can get enough to actually burn you, char flesh, and things like that. I'm not sure where your normal house current applies. It sort of depends on how good a conductor you are to ground.
Yeah.
And how moist you are when you do it.
Yeah, if you're, and I had this situation come up one time on a ship in the shop. The last day of, I mean, we got 24-hour a day coverage, but the last shift of your work week, when you've got 2 days off, they would generally send people home at lunchtime to get their weekend started early. So this one guy named Felix, the supervisor, told him when that ARN-52 is finished, you're out. Take off. So Felix was working overtime. So he was perspiring, a little damp, concrete floor, steel metal stool, typical Navy shop. And he's got these 4 power tubes, and there are wires going to them, and they're powered by 2100 volts. And when you test it, you go into transmit and it blows a fuse. Well, then the first thing to do is to pull all those wires off of those power tubes and point them up and fan them out so that nothing arcs. And then you turn it on, and if it doesn't blow the fuse, then you know it's one of those tubes. So you start with the first one in line and start putting it back on. The problem is that you have to let that 2100 volts drop off, or you have to use a shorting probe to short it. And Felix didn't do that. He wanted to go home, and he wanted to go home now. So he grabbed a hold of that wire and it lit him up with 2100 volts. And he did leave the shop a few minutes later, but he didn't go home until Thursday.
Yeah,
Yeah. And we've noticed there was and the thing is, there's supposed to be a mat there that your chair is, that your stool is sitting on, but he had 2 off on the concrete and 1 on the mat. And so yeah, the stool came up off the ground a little bit, his behind came up off the stool a little bit, and there was a burn hole in the press board that was on top of the seat. But yeah, 250 milliamps, they say, can cause death. I've never seen it happen before. Of course, you don't really measure how much current is going through somebody. But with household current, same thing applies. When you start to perspire, your body's resistance goes down. So that, and resistance goes down, current goes up.
And it kind of depends on the path. Like if you had one hand on something grounded and the other hand you touch the high voltage line, it's coming right through your heart.
Through the upper chest cavity.
I remember the news guy in Palm Bay, he was up trying to wire a new fan. Putting the wire in for the fan like in his garage or something. That's what happened to him. He was sweaty and got across it and killed him. So she's up there.
Yeah. One of the rules is always have the other hand behind your back.
And
How does that help?
Mhm.
anything metal on your fingers or wrist needs to come off if you're working with high voltage.
Say that again?
How does that help? Having your hand behind your back.
Well, one hand behind your back while you're working, while you're taking measurements with the other hand means if you do get shocked, it doesn't go through the upper chest cavity where your heart is. If it goes from left hand to right hand, it goes through the upper chest cavity, and that is not healthy.
Wow, okay,
So
that's a good thing
We
to
try
know.
10 years, so you'll kind of get where we kind of did that.
And this is not unique to ham radio. This is
Yeah.
around your house.
All of it. And with regards to, Bob mentioned, household current. The other thing about household current is that it's 60 hertz rather than 400 hertz like aircraft power is. And the lower the frequency, the closer current will travel to the core. So that 60 hertz current is traveling through your basically your central nervous system.
Mm.
That causes problems.
So it can cause involuntary muscle contraction, which is actually one of the natural responses in your body that helps because your muscles, if you touch electrical wire that's hot, they'll contract and it tends to pull your hand away.
All their muscles contract and it's just.
Yeah, yeah.
Okay.
But if it's high enough, you sort of get glued onto it and you're screwed. And it just starts charring and you might survive, but not good. So what health hazard is presented by electrical current flowing through the body?
That would be delta.
Yep, boy, a lot of deltas today.
I like delta.
Okay, in your house or your shop, your shack, you want to make sure that you're using 3-wire outlets so that it has a safety ground. 3-wire cords and plugs, because it doesn't do you any good to have a 3-wire outlet if you're not carrying that safety ground to the equipment. Now, today, a lot of hand tools and appliances only have 2-wire cords because they have a insulated chassis, outer whatever, and they're supposed to be isolated, so you don't necessarily need that safety ground. I think it would be better if it did have it, but particularly on ham radio equipment where it's usually the transceiver is in a metal case for shielding for one thing. That needs to be tied into the safety ground. In the US, where we have 120 volts as our normal household current, you may also have 240. In fact, you probably do for a range or a dryer. But most of your outlets are going to be 120, and they have 3 wires where the white wire, or slightly off color white, is the neutral. The black wire is the hot line compared to the neutral. And then it'll usually be a green wire. It could be bare copper. Normally it's green. And that is your safety ground. And that is connected all the way back to your service entrance, going to a ground rod outside where your power comes in at your meter. You want to make sure that you connect all of these devices in kind of a star or single point ground fashion. You don't want to have a daisy chain. Because the point is you want to keep everything at a constant potential. So even though you could have a lightning hit close by and have some current coming on the ground line, and it would raise the voltage, you want everything raised so there's no difference in potential between components.
Current can't flow if there's no difference in potential.
Right. And the less difference, the less current.
So remember, in today's world, like your base equipment, most of it all runs off 12 volts. So you get a power supply that produces the 12 volts, it's plugged into the wall. The rest of your equipment isn't plugged into the wall. There is no ground plug because they're on a 12 volt. So your transceiver, you might have a antenna tuner, you might have an SWR meter, all that stuff runs off 12 volts. So none of those equipments are directly connected with a three-prong plug. There is no three-prong plug.
But almost all of them will have a ground plug, so where you can connect it to your single point ground.
So years ago, in the 70s or whatever, it's been a long time, but all the equipment, every piece of equipment had plugged in. So you didn't hear a lot about grounding, ground rods and grounding, because every single piece of equipment was plugged in. It didn't work off 12 volts, so now over the years, they've changed in that direction. So this is one reason, many reasons, but it's kind of like, why do I got to tie it to a ground if it's plugged in? Well, most of it isn't plugged in except the power supply.
So you said they all have grounding lugs, so you tie all that together, and then what grounding source do you use?
You connect it to your station ground. So wherever your quote shack is, even if it's a car, you'll have a ground that all your stuff is tied to. In the case of, like, if your shack is in your house, normally you may bring your coax in through a panel in the window, let's say. Right outside, as close as possible, you should have a ground rod, and you tie whatever's inside to that ground rod outside, preferably with copper strap.
Like a separate driven 8-foot ground rod?
Right. And we'll get to it a little bit later. That should be connected to the ground rod at your service entrance with at least number 6 wire. And it doesn't hurt to have another ground rod every 8 or 10 feet. You can't have too many ground rods.
6 feet is code right now.
Huh?
6 feet is code on a new house. Two driven ground rods 6 feet apart.
Oh, that close?
At least, yeah. At
That's
least
kind of a lot of overlap, but yeah, all right.
I'd like to be at least 12, but it has to at least be 6 in COVID. Better than 12 because ground saturation if they're too close.
A lot of panels are grounded to your copper water pipe as well.
That's not a good thing anymore because newer houses don't have copper.
That's CPVC.
And definitely not to a gas line pipe.
Correct.
And if you got equipment has high voltage, like a power amplifier, you want to make sure that it has some kind of interlock. So if you take the cabinet off, or if it's got a door, that there's some interlock that cuts the power, so you can't be in there even if it's plugged in and have it operate. And also, that's where you want to have one hand behind your back. This is kind of an example of typical setup where you got your power line coming in the service entrance, and there's a ground rod at that point, and you've got your safety ground, which is carried through the house wiring. So anything that's plugged in to an AC receptacle is tied into that safety ground, which, by the way, is not a very big wire. It's maybe 18 gauge, 16 at most. It's not really there to conduct lightning current. It's there to short any short in your equipment, whatever that is, say it's a power drill or a mixer or whatever, if there's an internal short, the purpose is that that gets shorted to the safety ground back outside instead of through you to the ground. It doesn't make a very good ground in the case of a lightning strike, which is why all of those ground rods should be all tied together externally, not through the house with a heavier gauge wire.
Mm.
So in the United States, what circuit does black insulation indicate in a 3-wire 120-volt cable?
Bravo.
Bravo. Now, if you had 240 volts, you'd have a red wire and a black wire and a white wire. What is a good way to guard against electrical shock at your station?
I think so.
Delta.
Another delta.
Uh-huh.
Okay, fuses or circuit breakers are used to protect from excessive current or overload. Basically to prevent a fire, because if you didn't remove the power and you got an overload and the stuff's heating up, eventually something's going to catch on fire. You need to put fuses or circuit breakers only on the hot side. You do not want to have a break in the neutral or ground side of the circuit. And of course, you don't want to put in an oversized fuse, kind of like in the old days when you didn't have a fuse and you went down in the basement and you unscrewed the bad fuse and you put a penny in. You still see screw-in fuses?
Yeah, I hit one
Really?
the other day down Malabar.
I never seen one.
And it was a blown fuse, I could see it,
Okay.
glass.
Yeah.
I unscrewed it, a penny fell out. I left the fuse out. I said, man, we need to call electric. It
Well, I guess that's one way to hold the penny in, right?
is.
Yeah. Burn the house down too.
What is the purpose of a fuse in an electrical circuit?
Um,
I didn't hear you, Brenda.
I'm reading. Delta?
Now, Brenda,
I told you I like Delta.
She likes
not in this case.
Okay, all right.
You want to remove the power in case of an overload. Where should a fuse or circuit breaker be installed in a 120-volt AC power circuit?
Alpha.
Oh. Well, I can't remember whether the series or parallel.
Alpha.
Well, I give you a clue. You don't put fuses in parallel with anything.
Okay, that would be Bravo then. In series with a hot conductor on. Yeah. Bravo?
Nope. Try again.
That you-
Well, I'm running out of options.
Only on the hot conductor.
Remember your old Christmas tree
Series.
placement? Both were in series and one blows everything's up.
Yes.
If they're in parallel, you know what bolt goes out, the rest of them still not. But when it comes to a fuse, you want everything to go out.
We gotta check
So it's
every
definitely
one
serious.
Why should a 5 ampere fuse never be replaced with a 20 ampere fuse?
Uh,
It's not Delta.
Charlie,
Okay, you're back on track. When you're working on a power supply, and I think this would also apply to a power amplifier, you should definitely unplug it or disconnect the power before working on it. In the case of a power supply and also a power amplifier, you could have capacitors used for filtering that could have some high voltages on them and hold a charge for a very long time. In a proper design, it should have what we call bleeder resistors across the capacitors so that over a period of time it discharges it. You can't necessarily guarantee that they designed it that way or built it that way. So you need to make sure they're discharged. You can either put a voltmeter on it, measure it, or as Dan mentioned, get a shorting stick, which you can easily make, and clip it on the ground and touch it on there and draw a little arc and discharge it. And always keep one hand behind your back. So what hazard exists in a power supply immediately after turning it off?
It's flux capacitor.
You should get this one, Brenda. It's your favorite number.
I'm hesitant to say it's Delta.
That's right. Okay. We sometimes deal with 12-volt storage batteries. In your car, if you've got a mobile unit, you're going to connect it up to your battery. If you got a base station, a lot of people will have 12-volt storage batteries so they can run in case of a power outage. A lot of cases they'll put solar cells in a charger to keep the batteries charged and an inverter to run off of. If they're lead acid batteries, which is the cheapest option, they've got sulfuric acid in them. So they're somewhat dangerous if they were to explode, which can happen if you overheat it very rapidly. And one of the ways to do that is to short the terminals. If you accidentally dropped a wrench or something and it landed across the terminals of a 12-volt car battery, it will glow yellow very quickly, cause the battery to start outgassing, possibly cause it to explode, and then you got sulfuric acid splattering around. The outgassing is not good either because it's hydrogen. So you're mixing extra hydrogen with some of that oxygen, so the heat could cause that to burn. And oxygen and hydrogen make a very nice bang when you ignite them. So even a regular car battery, there's some danger. And the same thing in your station if you're using them for backup battery supply. Now, more people are going to the lithium iron phosphate batteries, which don't have sulfuric acid. If you short it out, it could still blow up because it's got lithium in it. Lithium and water don't like one another at all. Lithium burns in the presence of water. So they're probably just about as dangerous.
Are those the little lithium batteries and the skateboards that were catching on fire?
Yep.
Cause they're charging them and they were.
Yeah. Overcharging them or trying to discharge them too fast can cause overheating. Uh, the lithium iron phosphate are a lot safer than some of the other lithiums. Lithium poly being the worst, which is what we use for model airplanes because of the storage to weight ratio.
Mhm.
But you know, they're in a plastic package. It's like a plastic bag.
Mhm.
And if it gets punctured, then you've got lithium exposed to the atmosphere.
Mm.
And they can, well, I've seen pictures of them where the battery was damaged and it caught on fire, and it's like thermite. It melted its way through the floor of the guy's Jeep. I mean, it's hot enough to melt steel. Which of the following is a safety hazard of a 12-volt storage battery? This is not Delta. You got a guess?
Well, that would be, I would say, Bravo.
Okay. What hazard is caused by charging or discharging a battery too quickly?
Alpha.
Alpha. Okay, so electrical shock from whatever the source can cause damage due to heating of the tissue, actually called a burn. It could disrupt cell functions like your like fibrillation in your heart, because it messes with the nerves, and involuntary muscle contraction, which can possibly disconnect you from whatever the source is, but you'll have some painful muscles after that. You should always try to use 3-wire cords and plugs on your equipment. Everything should be connected together in a star configuration to a common safety ground. A typical thing you'll see in a ham shack is maybe a copper plate or a piece of copper pipe, like fastened on the wall, and everything is connected to that, which looks, it's a large enough conductor that it looks like a single point, and then that's connected to your outside ground rod. And try to put interlocks on any high voltage equipment. Fuses are there in case of an overload to prevent basically fire. Should be installed on the hot lead only, which is typically, it should be the black wire. I've seen cases where electricians didn't seem to know the difference. And don't ever put a larger fuse in the circuit than what is required for. You might have high voltage capacitors and a power supply or a power amplifier. You need to make sure that they're discharged and that the equipment is off. If you've got a storage battery, the danger is overcharging it or discharging it too fast, or shorting it out, which is discharging it too fast, can cause overheating and outgassing and possibly fire or explosion.
from